Alright, good morning. I hope I'm visible and audible. I don't see myself online yet, but I'll assume that I'm streaming. Sorry, we started a little late because this transition. Okay, thank you. Okay, so it's confirmed that something is coming. So let's start. Now, I wanted to finish systemic anatomy this month. That means this week, which means tomorrow. And there are still 5 systems left. But since you'll be doing organs and tissues within those systems in great detail, I will do an overview now because most of the things we will learn about in the next few systems are something you already know from 8th grade biology. So it's just like a little revision, especially for those who may have a language challenge, who may not have had an opportunity to revise or remember anything after MSET. There's been a long gap before you join medicine. So it's like a quick refresher overview, just a recap of what you already know about the system. So let's launch into that. I'll try to finish this overview for 3 systems today and 2 more tomorrow, and then we are done. After that, we will get into regional anatomy, upper limb proper, which I've already taken one introductory class for. And we will actually take classes paralleling what you should be doing in dissection in the practicals. I hope by that time campus will get opened. I'm a very optimistic person, though they say that campus for the first years is still under question. It's under a cloud whether you will be allowed on or not. And then after that your seniors will be there for the exam, so then you will not be allowed because of the security of the exam. So let's see how it goes, but at least we will get online and we will get started with the upper limb from next week onwards. So systemic anatomy we have already done many systems before. We did digestive and then we did respiratory and circulatory yesterday. Today I'll just overview the excretory and reproductive systems and the integumentary system. So let me see what I've got here. This is one. Just a minute. All right. Now, in excretory system, you already know what the components are, and you know that the function of it is to take out waste products from the entire metabolism which is running the body, and to continuously eliminate them so that they do not interfere with the healthy functioning of the remaining tissues. So we know that our excretory system already consists of 2 kidneys, a pair of organs which are occupying the retroperitoneal space in your abdominal cavity, and they are being nourished by branches from the aorta called renal arteries, and their carbon dioxide and excreted their metabolism output is being returned to the heart via the renal veins. So the blue ones are the renal veins, and behind them will be the renal arteries, and behind that will be 2 tubes which start from their concave medial surfaces, which is called the hilum of the lung, renal hilum, and they go inferiorly and medially. These 2 tubes are called the ureters, and they converge towards a single unpaired centrally placed sac-like organ called the urinary bladder. Now, the 2 kidneys, the 2 ureters, the singular urinary bladder and the singular urethra together constitute what we call the excretory system. But excretion in the body is not done only by these. It's also done to some extent by the skin. And yesterday we said the lungs are also a place where some amount of excretion is done, because if you consider carbon dioxide and water vapor a waste product, then some of it goes out in your breath also. As an aside, do you know that alcohol is excreted in your breath? That is what is the basis of the breath test, breathalyzer, which they do for drunken driving, right? At least some of you youngsters might have had a close encounter with that kind of experience. I hope not, because probably you all are not of legal age yet to be drinking, leave alone drinking and driving. And for God's sake, don't ever do that in your lives. But I'm just saying, this metabolism of excretion is not done only by the kidney and its related organs, but by other organs also, which technically belong to other systems. This should give you an idea that this division into this system, that system, this compartmentalization is a very human science, mental, intellect, left brain thing that we do. For you, the organism, all of it works together, and all of it multitasks. Your circulation will be doing other things, your respiration will be doing, respiratory organ will be doing other things, what you think is a digestive organ will be secreting some neurohormones, what you think is a sensory organ will be probably producing some vitamins or something like that. So multiplicity of function is a phenomenal feature of advanced life. Remember that. And it's amazing because with a little bit of tissue and a little bit of juxtaposition, a little bit of interconnection, a lot can be achieved in a very efficient way. On the other hand, because it's not a single time, one time de novo constructionist procedure, the process of evolution has made many things very useful and very strong and very well established, whereas other things have had to die out, but not in a single stroke. Slowly, their functions become less and less, or they become temporary, and later at some point in the evolutionary tree that will no longer exist in that next species. Right? That's another fascinating thing, but more about that in another context. Coming back to our excretory system, the two kidneys, where the medial part from which the ureter starts is called the renal pelvis. Here they're showing that these kidneys are tucked right under the domes of the diaphragm, where the esophagus is coming through, and the hepatic veins are also seen as branches of the inferior vena cava. These are irrelevant as far as excretory system is concerned, but they are all together. So why this needs to be an anatomy topic is because obviously it is right next to things belonging to other systems, and things which have got no relation functionally with each other may share a blood supply, or may share a nerve situation going through, or may just be related to some third thing which will get involved in the same disease process, which is why you just need to know relationships of one thing to the other. And there are a few million of them. I'm not trying to scare you, but you just need to know what's on top, what's at the bottom, what's on the left, what's on the right. Many times there's no answer to why is it there. We just know it is there, and you have to know it is there, because then you will be able to predict it, plan for it, and conduct the surgery which is required to cure your patient. So coming back to our excretory, on top of the upper poles of the left and right kidney, there's supposed to be one yellowish gland here. I don't know how sharp this picture is, which is called the adrenal gland. Adrenal, ad means next to, adjacent to, and renal is the word Greek I think, or Latin, which refers to the kidney. So wherever we have renal this, that, or the other, reno something, then that is a related to kidney structure or function. Renal artery, I've mentioned. Hilum is that concavity from into which the blood supplies are going, out of which lymph will drain, into which nerve supply will go, and so on and so forth. So it's a concavity into which the entire surface of the kidney is not going to be the area of supply. All the supply is going through one space, and that's called its hilum. Then the renal vein. The aorta is a central large artery placed almost halfway between the two, and the outcoming tubes which will carry the product of the kidneys is the ureter. So for the left there is a left ureter, for the right one there is a right ureter, and so on. Iliac crest is a bony landmark, we'll come to that later, but the point is that these are the organs forming the excretory system. When you follow it further down into the pelvis, these two ureters end in one central muscular sac. You can't make it out. The posterior structure behind that is a rectum. In front of that is a uterus, which means this is a woman, a female dissection. And in front of that, somewhere here, will be a smaller, when it's empty, it's quite small and collapsed, a urinary bladder, which will belong to the excretory system. So this you can make out is a school level, K-12 level of slide. The functions are removing the waste, therefore cleansing the blood, producing the urine, and being composed of kidneys, ureters, bladder, and urethra. Please remember. Alright, this is a section you all must have done a hazard times. You already know what it consists of. We'll be telling you the excruciating details in anatomy as we go ahead. Alright. So the essential modus operandi of this happening is a filtration mechanism, and that is happening at the microscopic anatomy level. You know that the unit of kidney function is called the nephron, which consists of a bunch of capillaries surrounded by a cup-shaped structure, a double-layered structure, which filters the contents of the capillaries, which is essentially blood, and takes away everything which the body doesn't require anymore, and returns cleansed blood back into the renal circulation, which means a renal vein is carrying away very clean blood back to the heart. Clean from the point of view of metabolic waste products. So most of that, I don't know, you must have seen, if you've seen blood reports, you've heard about people who are sick. We do kidney function tests, right? Like we measure the serum levels of urea, creatinine and uric acid. Particularly, not that only these three molecules are involved, but these are easy measures of kidney function. So if these levels are high, it means for some reason the metabolism is producing very high levels, or the kidney is not able to filter, because you're measuring a blood parameter, and if blood is efficiently emptying its wastes into the kidney, or vice versa, if the kidney is efficiently extracting the wastes from your blood, then the blood levels will be within a very healthy range. So a measurement of blood levels gives an indirect measurement of what the kidney is doing or not able to do. Alright? Once this urine is formed, which is containing all the waste products, and it comes down the ureter. The ureters are only tubes which will convey it. It goes down into this urinary bladder, a sac-like structure, and is stored there, is held there by a sphincteric mechanism at the neck of the bladder. This is where the little children learn how to hold their urine. Otherwise, whenever the bladder fills up to an approximate capacity, the babies below 2 and 2.5 years will automatically empty the bladder. There's a reflex mechanism of emptying a full viscous. But we have been given mechanisms which are in both. One level is involuntary, another level is voluntary, where we learn voluntarily with the skeletal muscle to hold the sphincter so that we can empty it at our convenience. And that is part of the function of the bladder, is to hold the urine till it is comfortable and convenient to void it. The purpose, of course, is to throw out all this waste from the body, now not keep it in the body anymore. Ureters are only tubes. Urethra is another tube which leads out from the bladder, carries urine to the outside of the body. Now the urethra is the one thing which is different in the male and the female genders of the human species. The rest is exactly the same, including the urinary bladder. And the minute the urinary bladder exit point is seen, in the male it is surrounded by an extra gland which doesn't look in the female, and that's called the prostate gland. And it empties its secretions also into this most first part of the male urethra. And then this tube itself pierces a muscular diaphragm called the urogenital diaphragm and comes into the space between the two lower limbs, that is the perineal space, a diamond-shaped area between the buttocks, which is the exiting area for many systems. It is exiting area for the urinary tract, for the digestive tract, we have already heard of rectum and anus, and for the reproductive tract, which we will talk about in a minute. So in that area, we have the exiting point of the urethra. Now in the female, there is no prostate. Immediately after urogenital diaphragm, it will get out and open into the urinary meatus of the female, into the perineum. So the whole length of the female urethra is only 4 centimeters. There's not much to it. And immediately behind the bladder in the female, there is a reproductive internal genitalia called the uterus, cervix and vagina. So this urethra is literally embedded in the anterior wall of the vagina. And is this intimacy, this close physical relation between the female urinary system and the female reproductive system, as they are becoming external, coming into the external space, is very, very surgically, and we will talk about it in great detail, particularly in relation to vagina and again in the whole speciality of obstetrics and gynecology. But by itself, the female urethra is a tiny little thing. It's only 4 centimeters. Usually doesn't get involved with anything much. There's no glands, nothing emptying into it. But since it is so short and so close to the external environment, it carries infection very, very quickly from external environment into internal environment, which is why female bladders tend to get more frequently infected than male bladders. What is called cystitis, inflammation of the urinary bladder. Nephritis would be inflammation of the kidney, right? Now, coming to the urethra in the male, we said it is surrounded at its neck of the bladder by an organ called the prostate. It is much longer because it enters into another organ called the penis and undergoes the length and the curvatures of the penis to exit outside several centimeters later, almost 10 centimeters later. So which is why the male urethra being longer, more curved and involved with other glandular secretions has a different biology, right? Because it is a common area for two systems, both excretory system where it is going to empty urine outside and reproductive system where it is going to empty seminal fluid outside the male tract. We'll come to that in a second. So, in the process of eliminating waste products by filtering it from the blood, the kidney also controls the amount of electrolytes, very, very important in maintaining your blood pressure, which is why the kidney filtration of sodium and the sodium potassium differentiation and how shall we put it, preferential filtering, adding or subtracting from the solute, that is from the glomerular filtrate, is a very, 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 very important function which will impact the pressure in the circulatory system, because the amount of sodium in the blood will determine the amount of water that is retained to keep it in a solvent state, and that blood volume will increase the pressure also. So the blood pressure control is not only happening at circulatory system level but partly operated by the sodium, potassium, water controls of the urine filtration mechanisms, which is part of your excretion system. Okay, this is again an 8th class question. I only wanted to show you for the pictures as a reminder of what it is that the structures are, where they are, how they differ in the male and the female, and what it is that they do to bring about excretion for the body. And here we only looked at excretion of metabolites which are being carried by serum everywhere, and when they come into the renal circulation, the renal arterial blood, they are filtered by these millions of nephrons, 1 million nephrons, both kidneys together, which are an exquisite biochemical control of what remains in your blood and what has to leave your blood, which has 3 or 4 levels of biochemical and hormonal control, loops of feedback, negative and positive feedback, which we will deal with in biochemistry. Reproductive system, as already mentioned, there are 2 different ones in male and female because we have 2 genders in the human species. There are certain earlier species which do not have a gender differentiation, right? They are all unisex. Their reproductive, I think you might have done it in, helminths, if I'm not mistaken. They have proglottids, right? They have their segments in which you have both male and female, and then you interchange of gametes and production of a new generation of species happens in a very, very, very different way. But in human beings, we have 2 completely, divergent developments starting with the same equipment. So when you see the little baby, the embryo, not even the fetus stage, you see that up to some point it is impossible to differentiate whether this individual is going to become a male or a female. And then suddenly, with the same raw material, with the same nascent tissues available, Under the influence of the Y chromosome, it will take off and develop into the male reproductive system. And if there is no Y, then the default is it will take off and become the female reproductive system. It's quite fascinating. We will study that in embryology, and we will look at its final effect in the adult systems that we have. Now, this is not a surface view of an adult man, but rather a hemisection. So we've taken a full adult male, cut them in half, and we are looking at the section of one side. So we see that this is anterior or ventral, and this is posterior or dorsal, and this would have been the man's anterior abdominal wall, and this would have been the buttock, the backside, this vertebral column. Right? This is the coccyx, sacrum and coccyx is here. So on the back side, or towards the back side, is the whole digestive tract. This you must have seen, where you have the rectum and the anus. On the front side, you have the anterior abdominal wall with the muscles. You have the pubis bone here, part of the pelvic girdle, and you have the male external genitalia, an organ called the penis, right? And then you have a muscular diaphragm here, which I had already called the urogen, continuing and anchoring or is occupying the gap between the bones to form a muscular partition where the internal cavity ends and the external genitalia. So inside of this muscular partition is the inside of your, and outside of this is all these structures are your external genitalia. Now in the male, external genitalia we have is the penis, and then there is a sac-like structure which is bilaterally symmetrical, which is called the scrotum, and in that is housed the male gonad, which is called the testis, one on either side. So in a sagittal section you'll only see one half, because the other half is not there in this in a section. So what we see is that inside the sac is housed an ovoid organ called the testis, and this is where the male reproductive system starts. It starts with the gonad. It's not like anything starts or ends. Everything is all there together at the same time at any given point of time in your patient. But we always talk as from the beginning of spermatogenesis to the ending, as if that's the beginning, the organ beginning and the organ ending. It's just a what should we say? It's a way of description which is global, universally understood. So we'll just go with that. So the male gonad is called the testis. There are two of them, equal, bilaterally symmetrically paired, positioned in the external genitalia is as contents of the scrotal sac. So there's a left and a right testis, and on top of it is an extra piece called the epididymis, which is a very curly tube, which at the end of it becomes a single thick, large, single lumen tube called the vas deferens.